All right. Can you hear me? So this will be interesting. Just rocking the mic on 1:40 a.m. on a Sunday. But yeah, it's a shame. Flat Earth Debates. I guess your name is Andrea. It's a shame what's happened, and it was so confusing how this channel icon with the two dudes at the podium, how like that got appropriated for free Chan. But so what I'll say is keep your chin up. The thing is, there's a lot of darkness in the world, but an infinite amount of darkness cannot conceal the light. That sounds, kind of new age, but dark is the absence of light, but dark can't conceal light, So all darkness is an illusion. It's a shadow. So you can imagine, on the globe Earth model, the dark side of the Earth is really an illusion because it's daytime all the time, right? It's daytime all the time. We're 93 million miles away. The sun is just as bright as it is, anywhere. But you sneak around behind the shadow of the Earth, such as when we have our night, and all of a sudden it's dark. And it's not dark because it's, there's some inherent darkness. It's an illusion of the Earth coming between the observer and the sun. So the sun is still there. The sun is still shining full brightness when we have nighttime. It's just an illusion. So that's what I would say to you, Andrea, is, if you've got the light and someone else has the darkness, the darkness cannot overpower light. I mean, that's a contradiction of terms. What it is light can conquer darkness. Like it's a one-way street. So yeah, you may get knocked down, you may get bruised and battered a little bit, but at some point, the light will always remain victorious. So I appreciate that. What you said, good values do not pay off in life. No, that is absolutely not true. It's very easy to see that. You're like, oh, nice guys finish last, and the people who get ahead are the people who are doing all the cheating. But then you take a look at their quality of life. Like, this has been memorialized in movies and stuff where there's, some greedy fat cat, blah, blah, blah. And it's not about the money, but it's definitely about, the person's approach. And then you take a look at their miserable relationships, because all they're interested in is screwing the next guy on the next deal. So, it can appear though that the way to get ahead is to be crooked, and that, the people with the best values end up last, but you have to look yourself in the mirror, at the end of the day, you have to look yourself in the mirror. And if you got to where you were by stepping on somebody's, neck, then could you look yourself in the mirror and like, I did really good today. I stepped on that person's neck and I'm proud of it. And it's like, no, and whatever gain you got from that, whether it was financial gain or something, you wouldn't feel good about that, unless you had no soul, and you don't strike me as the person who doesn't have a soul. So the thing about having good morals is that your conscience is clean, and you may look around you and you may see other people doing better than you. But I'm telling you, when you scratch beneath the surface, there are a lot of miserable people who are doing much better than you. And I'm not saying that all people who are doing better than you are miserable. I'm just saying there are a lot of people where it's like, they traded in morality for, the quick gain. So it's like, the thing is, being of good morals does not necessarily have the quick payoff. And in fact, the payoff may come years in the making. The thing is, the phrase "good things come to those who wait," and it's not a matter of waiting. Obviously, you got to take action, but right action. Ever since I was a teenager, the hormones and all that kind of stuff, adolescence, pining after a girlfriend, and oh, I wish I had a girlfriend, blah 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 blah. And it's like, meanwhile, all these, all the cool guys, they would just churn through girlfriends, and it's like, well, was that a meaningful experience for them? And then it turns out that I've had like 3 serious girlfriends in my entire life, and then I ended up getting married at the age of 40. And now I'm, very, very happily married. I've got a beautiful wife. She's the love of my life, mother of my 3 kids. But that took 40 years, that took 40 years of living to get to there. So, not that that's a promise, but good things must come to those who have the right moral values. And sometimes the good things may not even come on this mortal plane. The Mormons believe that you get your perfect body in the afterlife. Families are reunited, and that also people have callings. Crepuscular rays. Anyway, so what I'm going to say to you, Andrea, is keep your chin up. Keep your chin up. You got to keep fighting. I mean, you've been playing all these audios from World War II, and it's like, Churchill, all of his advisors told him to surrender. They're just like, the best thing you can do, Winston, is to negotiate the terms of Britain's surrender. That's what all the advisors told him to do. It's like, take the best deal. This guy Hitler, you can deal with him. Take the best deal, And he is like, hell with that. We're on the right side, And thank goodness he said, never give up, never give up, never ever ever give up. No, I'm not a history major. I know very very little history. But I like to listen to things like that, and I just can't imagine in the darkest days of World War II when Britain was just getting its butt handed to her, when America was losing so many people on so many different fronts. I mean, the story of the Japanese, the Pacific War. My wife had a really really fascinating book. I mean, you have to kind of be into it, but it's a history of the Japanese Navy from, I think, 1941 or 1940 to like 1946 or something like that, and it's by this guy by the name of Paul Dahl. And the thing is, we learn about Pearl Harbor. So Japan attacked us at Pearl Harbor, and then we had a bunch of battles, island hopping campaign, and then eventually we big battle at Midway, and then we were able to attack Tokyo, and then eventually we dropped the bombs on Hiroshima and Nagasaki. But reading that book, the first 2 years of the Pacific War, United States versus Japan, the United States was defeated. First 2 years, we got our rear ends handed to us. The Japanese military might was very, very powerful, and they were very organized. They had a lot of infrastructure, and we got our butts handed to us. But we kept fighting, fight, and eventually the tide turned, and we won that war. But anyway, that's what I have to say to you, Andrea, is never give up. If you know that you're on the side of right, and you got these crazy people who are obviously not, you're on the right side, that like there's no argument there. You're on the right side. So you just keep fighting, keep doing what you know is right. All right. Melchizedek, you asked about the sun. Says the sun is 4,000 miles away based on the angles of crepuscular rays. No, they actually don't say that. They say, and it's really key. First off, the sun's supposed to be 3,000 miles away in the flat Earth model, and that's based upon observations. If you take somebody at 45 degrees north latitude, which is approximately 3,000 miles from the equator, maybe 3,100 miles from the equator, and you look up at the sun on the equinox, you will see the sun at zenith. It will be at 45 degrees in the sky. This is a fact. When you are at 45 degrees north latitude, you will see the sun at 45 degrees in the sky on the equinox at zenith. Okay. Well, that makes a right triangle. If you draw the equator and then 45 degrees north latitude, and then you draw 3,000 miles from the equator and then 45 degrees, it makes a 45, 45, 90 right triangle. Therefore, the altitude of the sun is 3,000 miles. Okay. That's where they got the 3,000 miles from. Crepuscular rays are a very interesting phenomenon, because what the flat Earth folks say whenever they see crepuscular rays, otherwise known as God rays, sunbeams bursting through a cloud, the only thing they say, and you can double check every single video from a flat earther that mentions crepuscular rays. Okay, mark my words, they will only talk about the heliocentric model is 93 million miles, and that can't be right. The sun is much closer than that. So here's the point I'm trying to make. When they see photos of crepuscular rays, they only use it to attack the heliocentric model. They never bring in the actual value from the flat Earth model. So when you see this sun bursting through this cloud, anybody looking at that picture, not knowing the distances involved, will say, yeah, it's obvious the sun is right behind that cloud. So if the cloud is 3 miles tall, okay, the sun's right behind it. So the sun is 3 miles tall. You will never ever hear a flat earther say that. What the flat earther says is that the sun can't be 93 million miles. In other words, it's only used as an attack. And that's one of the very key things in the debate, the flat earth debate, is that there's certain things that they will only use to attack the heliocentric model, and they never turn the mirror on themselves and say, well, what about the phenomenon, the exact same phenomenon on the flat earth? How does that stack up? Because they talk about all this stuff being so ridiculous in the heliocentric model, but they don't realize that it's even more ridiculous on the flat earth model. So here we have these crepuscular rays, and that indicates the sun is about 3 miles in altitude, maybe 5 miles in altitude. But in actuality, it's supposed to be 3,000 miles. And you could easily say to the flat earth folks, you could say, oh, does it look like it's 3,000 miles in altitude? Oh, the flat earth is so ridiculous. Obviously, it's only 3 miles away. It's very silly, because the same crepuscular rays can be seen from, and you just Google it. You could see a streetlight behind a tree in a little bit of fog, and so you have these crepuscular rays, and you're like, well, where's the light source? Well, it's behind the tree. It's literally right behind the tree. The anti-crepuscular rays are interesting. I just saw them for the first time just a couple weeks ago. I actually took a picture of them, and basically the crepuscular rays are actually parallel, and the anti-crepuscular rays are, if you could stand and look up and you have the sun behind you, you may see anti-crepuscular rays in the right conditions, where the rays are converging. Like, they're not converging to the sun behind you, they're converging to a point in front of you. And what that means is that, no, they're not converging at all. They're just as parallel as they were when you were looking at the sun. Now you turn around and you get your back to the sun, and you have these anti-crepuscular rays. They look like they're converging. They're not converging. They look like they're converging because they are, in fact, parallel. But for some reason, there was that, I think it was P-Brain made a video on anti-crepuscular rays. And his explanations are just, they're very interesting, and I like to see his diagrams, but oh my goodness. Delacroix, good night. Oh my goodness, there's now a wrench next to my name. I didn't realize that. Thank you, Andrea, for the wrench. We got a good concepts here. So Timothy Lyon, do you have anything to ask about the heliocentric model, or that's my specialty. So what to say? I've been seeing some videos. Jaron had a video where he was just sort of driving around, just sort of talking about stuff. And then there was saw a video about the so-called New Bedford level experiment. And what strikes me is how frequently misunderstandings just get propagated. Like, one of the things that was in, I guess it was allegedly Dave's video on the New Bedford level hangout. I'm calling it an outing. He excerpted some stuff from Jaronism, where he was talking about the curvature not being 8 inches per mile, but rather being a third of a mile per mile. It's like that. I cannot get my mind around that. I understand where he's coming from. If you go a halfway around the circle, the hump height is the radius. If you go all the way around the circle, the hump height is sort of the diameter. So if you are going the entire way around the globe, what's the curvature? Well, the curvature amount could be represented by the diameter. So you take the circumference divided by, take the circumference multiplied by 0.319 or something. I don't know what the number is, 0.318, which is essentially the inverse of pi, or the reciprocal of pi. And then you get the diameter. I mean, it's basically, it's arithmetic. Pi d is the circumference. I mean, that's one of the first formulas you need to learn, pi d. Tinfoil Hatter. Tinfoil Hatter, hello. Sorry you can't. Well, if you want to join us, you're welcome. But I totally get where that circumference thing comes in, or where the 0.318 comes in. It's just wrong. But I mean, I totally get where he's coming from. But the thing is, he doesn't then extend the knowledge to real life. For example, Tinfoil Hatter. I'm sorry. Hi, this is Charles Breeling, otherwise known as Flat Earth Math. So essentially what he's saying is multiply distance by 0.318, which is pretty close to a third. All right. So that means that if you're going a mile, the curvature is a third of a mile, which, like, that just patently doesn't make any sense, because what he's now said is, regardless of the distance, you just multiply by the reciprocal of pi. But that, like even if you just drew it on a sheet of paper, or you took a hula hoop, just take a hula hoop and measure 1 inch. Like, let's say you're standing on the hula hoop, and then you want to see what's the curvature 1 inch away. Well, if you were on Earth, it would be 8 inches per mile squared, or I don't know what that translates to at a hula hoop. But according to him, it's a third of an inch. So if you go a foot on the hula hoop, or no, if you go an inch, I mean, that's almost horizontal, but he wants you to drop a third of an inch. Oh, hello, Gerald Sam. Good people. Hello, Mr. Bukkake Pies. I like hearing you debate Bob from Globebusters, because he's always like, I have video, Bukkake. And it's so funny. I have video. Okay. And it just sounds like he's got this big porn collection with a very specific genre in mind. Anyway, so that's Bob from Globebusters, who's a nice guy. I mean, I genuinely enjoy my my interactions with him. But I mean, so many people that they're so quick to accuse you. Like, for example, Mr. Bukkake, you have a telescope, and somehow Bob is yelling at you saying you don't have a telescope, or you don't know how to use it, and it's just like it's a big pissing contest, It was so silly, and it was really based on a misunderstanding, but I understand that the flat earth folks are coming from a place of, well, I'm not going to call it necessarily weakness, but they don't have a whole lot on their side. They are the underdogs. They do feel a bit beleaguered. Zoomed in footage from your digital SLR. Yeah. So yeah, a lot of people can claim a lot of things. It's a shame, but so when I'm discussing stuff with people, I get called every single name in the book. It's increasing my vocabulary, but I have to understand that, like, if flat earth folks are calling me names. Oh, here's Atheist Rex. Hello, Atheist. Anybody's welcome to join. I'm just here, just rocking the mic. But I really try to take the stance of the high school teacher, and I think that was one of the things that really pissed off Michael Craig, aka Hitch. Is he really was pissed off that I was trying to teach him. He clearly has misunderstandings about the heliocentric model. And so, you can believe what you want. You can believe the earth is flat. That's fine. It's a free country. It's a free planet. Believe whatever you like. But if you don't understand something about the heliocentric model, I'd like to help you out. Like, if you believe that the earth is flat, fine. You can believe the earth is flat, but don't have misconceptions about the heliocentric model. I would like you to get that, understood. So people are funny. All right. Magnetic declination is questionable at best. Magnetic north as opposed to true north. So yeah, and I'm not sure what the terminology is, but I was really surprised to find that the southern celestial pole was, the southern magnetic pole was so far away from the South Pole. I was really kind of shocked. It's something like, I don't know, 1,500 miles. Hello, Gerald Sam. Haven't seen you in a while. And so there was that video that Max Egan took when he was on a flight from, I think it was Santiago, Chile to Sydney, Australia. I'm just going by memory. And so you've got the little infographic in the plane clearly showing a great circle route, that's deviated significantly far south. Not exactly touching the Antarctic continent, but getting really close to Antarctica. And so at the point in his flight, he was flying northwest. Okay. He was flying northwest according to the map. And then he takes out his compass, and his compass says that he was going, something like west-southwest, something like west by southwest. So then they were like, that proves flat earth, because, the compass, blah, 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 blah. And it's like, these guys weren't taking into account where the magnetic South Pole is, which is basically in the same direction as the southern tip of Max Egan's compass. If you draw it out on a map, you have Max Egan's, you figure out where on the flight path they were, figure out where Max Egan, he had the compass pointing towards the front of the plane, and then where was it pointing north, or where was it pointing south? And it was pointing exactly to the southern magnetic pole, just as it would be if he were approaching Sydney, Australia from the southwest. I'm sorry, southeast, approaching it from the southeast. And the folks in the panel were like, look, this proves that it's flat Earth. And it's like, meanwhile, the guy's saying he's on a flight that would be, a 26-hour flight on a flat Earth, and it's 12 hours on the globe Earth. And they're like, yeah, you just proved. So there are so many examples where somebody has the evidence right there in front of them, and they draw the wrong conclusion, or they, confirmation bias is the classic example, the classic phrase, confirmation bias. I see a piece of evidence, therefore it confirms my model. I was talking to my chiropractor about this morning, and so he said that he was on YouTube and he was clicking on some stuff, and then a flat Earth video came up, and so he clicked on it, and it was something about shadows and how the shadows aren't lining up, whatever, and that's why the Earth is flat. And that's confirmation bias. So you see some shadows, and it's like, oh, well, these shadows don't line up, therefore the Earth is flat. And so the best way I could explain it to my chiropractor is think of a phenomenon, think of something that happens, in the natural world, like you wake up in the morning and there's dew on the grass. Well, a flat earther will come along and say, look, there's dew on the grass. That proves the Earth is flat. Because if the Earth were a globe, there's no way there could be dew on the grass. It doesn't make any sense. And I mean, I've seen this stuff in videos, not the dew on the grass example, but they just have all these examples of, a classic one is the glitter. I guess it's called sun glitter, where when you look out at the ocean, you're on the beach, or it could be a lake, ocean, whatever, and you look and there's the sun or the moon, then you will see a line of reflection from the shore to the horizon. I mean, literally a band of reflection, not a single reflection like it was a mirror. And then they take this to be a confirmation of the flat Earth. But the interesting thing is, the only thing that would produce that kind of reflection is a concave surface. So if you have a single light source the size of, say, the moon, like let's say it's not blinding, so you got the moon, which does take up a physical space in the sky. The only way you're going to have the reflection of that moon spread out from the shore to the horizon is if you had a concave surface. And I am not arguing for concave Earth. Absolutely not. That is the most ridiculous thing. But the reason why it does reflect in that way is because of the ripples. There's, a million ripples between you and the horizon. And so every little scallop of that ripple, one piece of that scallop is going to reflect the moonlight. And it just shows up as a solid band of reflection. But yet you got flat earthers saying, look at this reflection. I forget what the video was. I just saw it yesterday, or it was today. I just saw it today. And it was talking about how, I just had this thing on the beach, and it was like, and it showed what the reflections should look like on a concave Earth, on a convex Earth globe model, and then on a flat Earth. And only the flat Earth shows you this sun glitter extending from there's Snack. Hello, Snack. Yeah, you've got a good point, Tinfoil Hatter. Represent the Earth on a two-dimensional surface. Yeah, I mean that's something that's something that is problematic. Maybe they'll solve that problem with holograms. Hey, Aeon Aton, Aeonaton, have a question. Listen to this person. I'm sorry. Am I for or against flat Earth, or simply seeking truth? So Timothy Lyons, I am a globe earther. I'm a heliocentric model person, and the reason why my name is Flat Earth Math is because I embrace the math and science, math and geometry of the flat Earth debate. Like, there is no globe Earth debate. People don't walk around saying, what's your stance on the globe Earth debate? It's a flat Earth debate. So my name is Flat Earth Math. And so when I talk to people in person, and when I am on chat, and when I am interacting with people in the comment sections, I definitely have a heliocentric basis. But on my channel, my videos are agnostic, which means I've studied, really, really studied the flat Earth model, and I've studied the heliocentric model, learned a whole lot of stuff. So what I encourage people to do when they look at the videos on my channel is I'm encouraging people to make measurements. That's the key thing. It is not a question of belief for me. It is absolutely not a question of belief. No more than it's a question of, do I believe that I'm, sitting in a chair and it's like, yeah, I can feel it against my rear end, but I know I'm sitting in a chair. It's not that there's no belief there. It's a physical, I can look down, I can see the chair. I know it's the chair. So the globe versus the flat earth, it's not a question of belief for me, because you could discover it yourself if you make careful observation. And that's the key. People not making careful observations. If they were to make careful observations, they would find just everything lines up in favor of the globe Earth, in favor of the globe Earth model. So it's not, and the reason why people believe the Earth is flat is because of some very, very fundamental misunderstandings. And also, you could say, well, I don't feel like the Earth is moving. I don't feel like, for example, I'm near Philly. I should be moving 500 or 800 miles an hour just around the Earth's axis, 66,000 miles an hour around the sun. I don't feel that motion. I don't feel like I'm on a spinning ball. I don't feel like I'm going to fly out into outer space by centrifugal force. And so, these are all misunderstandings about the nature of human sensation and motion. And that's a really key feature is if you can't sense velocity. I guess that's the biggest thing. You cannot sense velocity. You can only sense changes in velocity. So accelerations, decelerations, and then technically centrifugal force comes from centripetal, P-E-T-A-L, centripetal, which means towards the center, centripetal acceleration. So that is actually another form of acceleration. You're literally accelerating towards the circle. So you could sense that as well. But the centrifugal force or the centripetal acceleration is so tiny that you just can't sense it. You can measure it with instruments, but you can't sense it. So yeah, tinfoil hatter. A fascinating study is on projections. The Mercator projection is almost standard. I mean, there's some really nice projections out there that try to take Mercator and try to dial it in a little bit. But if you just Google map projection, I mean, you'll find so many different kinds of projections. The thing is, it's impossible to hey Snack, it's called the volume button or the mute button. Please mute. So the thing about the maps is there is no such thing as an accurate map. An accurate map does not exist because no matter what, the map is going to have inaccuracies. And the idea that the goal for map makers is to try to minimize distortion. So like on a larger scale, like for example, the United States. Sorry about that, Snack. I didn't mean to kind of come at you like that. My father had tinnitus. He was a bomber pilot in World War II. Flew B-17s over Germany. So I think it was the high altitude stuff. But yeah, tinnitus. There's this thing called quietus. And there's also a thing that you could do with your head. Maybe this is more for inner ear thing, or where you can it's a thing that you do with your head that you tilt your head back and then to the side, and basically you try to get these things. You may have some crystals or something that are stuck in your cochlea or something, or in your the little fluid that's in your inner ear. There is some therapy. I think it's more for balance problems than tinnitus. But anyway, yeah, I'm sorry to hear that, Snack. But within weeks of each other, 1909, Robert Peary and Frederick Cook announced they had led 2 separate expeditions to the North Pole. The way you would tell that you got to the North Pole is by observing Polaris, and also sighting in. I mean, you could take measurements from the moon and the sun if you had the right almanac, the naval almanac for celestial navigation. But that's the thing. How do you know when you're at the North Pole? Well, your compass certainly wouldn't work because the magnetic North Pole is nowhere near the North Pole. So how would you know? You would use a sextant, and you would sight in on Polaris. And if Polaris was 90 degrees above your head, then you're at the North Pole. Now, the thing is, each degree of latitude is about 70 70 miles. I think it's like 69 point something miles. That's 1 degree of latitude. So if you had a sextant that was accurate only to say a half degree, and that's probably a pretty bad sextant, but I'm just making this up. But like, let's say your accuracy was only to a half a degree, then you could get to be within 35 miles of the North Pole, and you might say, oh, we reached the North Pole. In actuality, you got to within 35 miles because you thought you were sighting 90 degrees, but you were actually sighting, 89.5 or, 90.5, just slightly off. And, if Polaris was just slightly off, then you might miss it. It's an interesting thing what you're saying, tinfoil hatter. So, oblate spheroid, more accurate than a sphere. But the Mercator projection is, it is just a projection. But there are a bunch of other projections as well. The equidistant azimuthal equidistant is yet another projection. Flat Earth perspective. Flat plane is first modeled into a ball, and then next to the ball is represented as a plane again. So the interesting thing to me, tinfoil hatter, is, and you could just, look this up either on eBay or even just, pictures from old movies. Like there were very accurate globes dating back, well over 100 years. So the idea that the Earth is a flat plane and that cartographers genuinely don't know the shape of the Earth, or that cartographers, every single one of them, is in on the conspiracy. And then they take this flat plane, which would make the simplest maths. This tinfoil hatter, this is really an interesting scenario, but it gets kind of ridiculous because one of the problems with map projections is they're trying to project a portion of a sphere or a spheroid, right? A portion of a sphere onto a flat surface. But the thing is, there would be no need for projections if the Earth were flat, because the map would match the model. The map would match the Earth. Atheist Rex. I got it in an email. Let me see if I can. I don't know if I can email it to you because I don't know how to use all this stuff. But that's the silly thing about cartographers don't just draw pictures based on mathematical formulae. That is absolutely incorrect. The cartographers, the original maybe today cartographers just sit behind a computer, but the original cartographers were surveyors. They went out into the field, taking measurements, getting measurements from other folks who are other surveyors, and then collating all the data to reflect a map. That's why they were able to map. It's like we take pictures from outer space, and somehow the globe looks like a globe that was invented 200 years ago, and accurately drawn 200 years ago. And that's why Australia is approximately the width of the United States. It is not 3 times the width of the United States. If you try to go east to west on Australia, it'll take you about the same amount of time as you going from east to west on the United States. And so clearly something's wrong. So if the flat Earth map has Australia all stretched out, then Melchizedek, I'm sorry if I came at you wrong. But the cartographers that we're talking about are the ones who were like in on the original conspiracy. They're the ones who made the first globes. They're the ones who made the first maps that are supposed to be so inaccurate. All right, let's see if I can get to my channel. I'm just going to narrate this. I have no idea how this works. I'm very frustrated by how YouTube doesn't let me know. All right, I'm in Creator Studio. All right, community. Doesn't let me know when I get an email. Or messages, right? So can I click reply? No. Oh, I know. I could just email to dude. Copy. And then we're going to go to subscriptions. Where's Atheist Rex? Atheist, do you have a channel? All right. Oh, can I send you a message? Yes, I can send you a message. All right. So Atheist, I'm sending you a message. I didn't realize you had a channel. Okay. All right. So Atheist, check your inbox. On me, the little bell does not show. I'd like to ask a question. If the world was a large spinning goal of constant velocity, what would it feel like? Okay, that's a very good question. So I'm only going to talk with the heliocentric model, which has the Earth spinning extremely, extremely slowly. Now, people are going to say, no, it's spinning very, very fast. 1,000 miles an hour at the equator is fast. Well, 1,000 miles an hour is how we describe vehicles, space vehicles, or vehicles that are going like aircraft, supersonic aircraft, the Concorde. That's how we talk about 1,000 miles an hour. If you're talking about a planet, 1,000 miles an hour is not an appropriate or is not considered to be a fast speed. 1,000 miles an hour on a planet scale is extremely slow. So how do we describe speed or spin? We describe it with units like RPM. So we all know record player, 33 1/3 RPM. Basically, it's spinning 33 times per minute, or approximately it takes 2 seconds to go, I guess, once around. So what's the RPM of the Earth? The RPM is something like 0.0007 RPM. 0.007 RPM Earth spin. So now that we know what the spin of the Earth is, that doesn't sound like it's very fast, because it isn't. It is literally half as slow as the hour hand on a clock. And that's really why I talk about misunderstanding. I'm always talking about misunderstandings. If you look at a clock and you point to the hour hand, do you use the adjective spinning to describe the hour hand? No, you use the adjective nearly motionless, right? It looks motionless, but we know the hour hand does move, so it's not motionless, but it is almost, in fact, motionless. It is spinning so slowly. Well, the Earth is spinning half as fast as the hour hand. So the question was from Gerald, what would it feel like? Well, you certainly wouldn't feel the velocity. If you're standing on the equator, you would not feel like you're going 1,000 miles an hour, because the air above us is also traveling 1,000 miles an hour. You can have a little butterfly that's floating by and lands on your shoulder. That's not going to happen if you're in the middle of something that's 10 times more powerful than the most powerful hurricane. So the air is traveling with us, the land's traveling, the velocity is not changing. If you're doing 1,000 miles an hour a second ago, you're doing 1,000 miles an hour now. There's no acceleration, deceleration. So in other words, you're not feeling the speed and you're not feeling the wind. The last part, Gerald Sam, is would you feel the centrifugal force? And this is where people really overblow the spinning. Water doesn't stick to a spinning ball. And there's images of somebody takes a tennis ball and gives it a wicked spin, and then they take a picture of it with a high-speed camera. And so you see these spiral arms of water, spinning off of this ball. I've even seen a video where a guy took a drill bit and stuck it into a ball and soaked the thing in water, and it might have been a tennis ball as well. And he had the drill, of course, all the water just spun off that ball like nobody's business, right? And well, that's dishonest. The Earth is spinning at 0.0007 RPM. The drill is spinning at 100, 200 RPM. So that there's some dishonesty with some of that. Even the language, spinning ball. People say, "Do you believe in a spinning ball?" I don't believe we live in a spinning ball. I believe we live on a very, very slowly rotating planet. Right now, Gerald Sam, the third part of your question, the third part of the answer to your question is, do you feel the centrifugal force? So you can actually calculate it. Centrifugal force is based on angular speed, which means something like RPM, angular speed, and radius. That's it. Angular speed and radius, and then of course your weight, your mass. So a 200-pound man on the equator, or actually it doesn't matter how much the man weighs, the centrifugal force is 1/3 of 1% of your weight. So if you weigh 200 pounds, you weighed yourself on the North Pole, and somehow you were able to zip down to the equator, which is 6,000 miles. Somehow you were able to go 6,000 miles without drinking anything, without going pee, without eating anything. Instantly, go from the North Pole to the equator, you will weigh 12 ounces less. Like if you had your scale, you stand on the scale at the North Pole, it says 200 pounds and 0 ounces. Then you jump down to the equator, step on the exact same scale, and it will say 199 pounds and 16 ounces and 4 ounces. All right, so you lost 12 ounces. And so it's imperceptible, right? It's imperceptible. And that's the worst case scenario, which is the equator. I'm only doing 800 miles an hour here at Pennsylvania, west of Philadelphia. And so I'm still doing the same 0.007 RPM, but my radius to the Earth's axis is a lot less. So therefore, my centrifugal force is less. There is a very interesting thing it's called the GNOME experiment. Let me see if I can Google this. The GNOME experiment. And the GNOME experiment, and it's from a guy or a company that makes precision scales. And what they do is they had this little garden gnome and a precision scale, and they sent him around the world. It was in this little kit with a dust, canned air, it's dust, the spray air, and lab gloves, and then you're supposed to measure how much he weighed, and lo and behold, he weighed the most in Antarctica. That's his heaviest weight, was 309.82 grams. The second highest weight was in I think Norway. No, it was in London, which is okay, it's pretty far north. 308.54 grams. The least he's weighed was in Kenya on the equator, 307.52 grams. So there's an example. Now the data is messy, right? The data is not all perfect. There's for some reason he weighed a larger amount in Los Angeles. Yeah, it's pretty cool. So I mean, the thing about data is a lot, and I'm really surprised that Bob from Globebusters, he'll see one data point and he says that without a doubt, absolutely undebunkable with 100% proof of something. And it's like, wait a minute, you just collected a single data point. And so the data is messy. But if you were to chart out this data, you would find a correlation. A little bit of messy. It's data is usually messy. I mean, we don't know if the scale got bumped or maybe if there's like for some reason a slightly stronger gravity because of the density of the crust beneath your feet. But if you were to map that out, and I mean, in all my free time, I mean, I'm really working hard being Mr. Mom, and I'm actually teaching a little bit of summer school now. But there's a bunch of data points here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I count 19 data points. No, they're not 19 data points. I think I double counted. There are, let me count again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 data points. So what you could do is take the 16 data points, take the amount of grams, and take the latitude, and then plot it and see what the difference is. And basically, the further you get from the equator, on average, the more you weigh. And that was a very nice demonstration from the folks. And the thing is, the Kern people, I read somewhere it was basically they hired a public relations campaign or a public relations company, and they're like, we want to get our name out there, and they're like, hey, why don't you try this? And it's sort of a public relations stunt, but it's kind of neat, interesting data. I'd never heard of Kern before, but yeah, if you watch the little video, it's kind of cute. It's like a 5-minute little video. So, anybody want to? Oh, I'm sorry, Atheist Rex. I didn't realize you were in the Hangouts. Oh, okay. Okay. I'm sorry to hear about those people. Okay. Yes. Okay. Okay. So, Atheist Rex, you want to jump on the mic?
No, not really. I've been enjoying yourself having a go at it.
I'm just doing late night radio, but I'd much rather talk with somebody.
I was in that position once a couple of weeks ago, so.
So what's on your mind?
Nothing. Nothing's ever usually on my mind. It's like I'll join a flat Earth debate channel, and I usually try to pick everybody else's brains or lack thereof, and see where that goes.
All right. Well, you got any picking you want to do with me? Because you and I depart on some key thing. You believe that 9/11 happened the way it happened. No, you believe there were planes on 9/11 because you actually saw them, right?
Oh yeah.
Okay. So I thought it was really inappropriate that one dude, I'm just not going to name his name, was kind of yelling at you and basically there were no planes on 9/11, and it's like, dude, I saw them. Oh nope, there were no planes on 9/11. But you and I differ. I forget where we have a. Are you I can't remember whether you're a glober or a flat earther. Because I know, or whether you even think that 9/11 was an inside job. You think you saw the planes.
Oh, I don't know what 9/11 has to do with anything, but no, I'm a globe earther, of course.
I'm sorry, what?
I'm a globe earther, of course.
Globe earther, right? Okay. Yeah, there was some key thing that I thought you and I differed on. I'm thinking of some other reptile. So I don't know that much about you, and again, I don't want to be like all tell me about your personal life. You feel free to just defer. But I'm a school teacher. I'm now on the cusp of joining a cyber charter school where all the instruction instruction happens over the internet, which will be very interesting. But what I'm understanding is that these kids who are just like, they're one step away from dropping out of school. They've already dropped out of like an actual brick and mortar school, couldn't handle the school thing, and I totally get that. And this is in inner city Philadelphia. It's tough population of kids. But to throw these kids a lifeline, they're like, hey, just enroll in this cyber charter school, and then maybe this works out for you. You can just do all the stuff from home, and maybe it works out for you. So it is a tough crowd. It's a crowd of people who are practically dropping out of school. And then I'm sure there are some motivated kids, but there's got to be a reason why you're not attending high school. So I'm going to be a teacher, possibly in the fall at the cyber school. Anything new with you?
Nope, kind of off this entire week. So hanging out, staying up late, sleeping in, going to the beach.
Do you have kids? Older, grown, left the house, something?
I have one child. She lives with her mother, and I have 7 nephews and nieces and 2 honorary nephews.
Oh, that's awesome. And you get to give them back, but I'm sure they're a delight.
Yeah. Well, no, sometimes I don't get to give them back.
Oh.
Sometimes they're dropped off and left there.
Oh, okay. Well, I guess
which is okay. I've got an open house policy on that.
Okay.
But boy, do they love to abuse it.
Well,
and it's okay. Sometimes I'd rather have them around me than up to their own devices or, neglected by their parents. I mean, they're not neglected, but they're
right. But as an uncle, I think you can have an interesting relationship because you are clearly not the parent. So you can take the friend role, because your parents are your parents, but you could be a friend, but you can also be an advisor, somebody who can help mold the young people along.
Oh, it's definitely obvious because they usually come to me with their burning questions.
Yeah. Did you ever see a movie? I think it's called Quince Años. It's a Spanish language movie. And I think and I'm butchering it. Quince Años is, if I'm not mistaken, it's 15. It's the 15th birthday, your celebration. It's sort of the I guess they used to call them coming out parties, but it was a coming of age celebration. Am I ringing any bells?
No, I haven't seen it, but
okay. But you know what I'm talking about? How in cultures, different cultures, there would be like, all right, this person has entered adulthood, and we're going to throw them a party, and I forget what was it, coming of age, or but it was a party. So this woman, she's I forget what culture she's from, but it's a Spanish culture, and so she's having her 15th her quinceaños party. But the movie has a very interesting cast of characters. There's mother and father, and then there's some cousins, and then there's this uncle. And there's this tough kid. When I say kid, I mean he's 20, 21. Looks like he's maybe getting involved in a gang, getting involved in some activities, not so good. And there was this party, a nice family party, and then this kid shows up and he's all tattooed and war of words, and he's cursing somebody out, and throws a punch, and then he's asked to leave, and so it's like, I'm watching this movie, and I like all the characters all look nice, but then there's this dude, and he's just causing problems. But then the movie shows this guy showing up at his uncle's house, and this is the thing that really struck me, and I really think back at this repeatedly, because right now at this point in the movie, I don't like this kid, like this guy needs to be told where to go, and he needs to be set straight. And he goes to his uncle's house, and the uncle tucks him under his wing. The uncle shows him love, gives him a place to stay, and is just basically a rock in this kid's life. And this kid is obviously going through a lot of stress, and it's like it caused me to look at that kid, when I say kid, 20-year-old, with new eyes. It's that he's not just, a miserable human being and just ruining everybody's good time. It's like, well, he's got issues too, but thank goodness for that uncle, because that uncle could have reacted like I would have reacted, which is get the hell out of here. You find your own place, But the uncle, gave him a place to stay, and it's like that's how you can help. That's how you can help this guy. This guy's obviously troubled. And the thing is, it was a gesture that was obviously out of love, not out of, oh, I'm going to defend you and all your wrongdoings. Like how some families, they close ranks. Johnny murders somebody, and then therefore we're going to defend Johnny. It wasn't like that at all. It was out of love, and it was clear it was out of love, and I was really struck by that.
Well, I find that uniquely, I have more time to devote to the kids.
Okay.
I mean, both parents are working and things like that. And, 3 kids on my brother's side, 4 for my cousin, they're just out of time and sometimes out of patience, with their own children. And that's understandable. And, the kids understand this as well. They don't feel neglected. They have everything they need. But, I can actually sit and listen to their little thoughts and respond to them. So that's wonderful. I love that about me and them.
Well, it's nice you have that relationship. What ages are we talking about?
My brother's kids are hitting their teen years, and my cousin's kids are still in their single digits.
Okay.
So, and I don't know when this came along, but my cousin's wife, I don't know, when the girls act up, like I heard her say it over the phone while I was talking to my cousin. She was going, I'm going to tell your uncle on you. And, I was like, is she using me as a boogeyman? It's like, when did I become the great dictator? It's like they love coming over here. But I think she understands that they really value my approval of them.
Right.
So, if they're acting out or behaving badly, she'll say, "Oh, I'm going to tell your uncle," and they'll suddenly realize, and he won't approve. Therefore, we should behave.
Right.
So the parents, I find, we all did it with our own parents, but other children try to test their parents' limits, the bounds of their authority over them. That's just human nature, I think.
Right.
And
right. It's a limit test.
With me, they don't dare.
Yeah, I'm finding with my own little children, limit testing. That's the name of the game, and you just you obviously love them, but you have to respond appropriately to limit testing. Limit testing is not love testing. It's limit testing. So it's like, I love you, young man, but if you do that one more time, here's the consequence you're going to receive. And then he does it one more time, and he receives the consequence. And with my one son Mars, oh my goodness, he was so hard-headed. I mean, he was in timeout for I think the entire age of 3. And then right around the time that he stopped getting timeout, his brother Orion started testing boundaries, and developmentally they're very, very different from each other. They're fraternal twins. But Orion, he lasted only a month with his limit testing, with his timeouts. That was enough for him. But Mars, oh my goodness, Mars is so stubborn. He's our mixed martial artist. We just sent him to the ER for his 4th time in his short little lifespan of 4.5 years. He's been to the ER 4 times, and this time it was for a corneal abrasion, and we still don't know how he got it. I think he was horseplaying with his brother, and his brother, I think, probably scratched him in the eye. But neither of them are talking. What happened? I don't know. So, but he's I gave him an eye patch for about a day, but the doctor said that wasn't. I just wanted him to keep his eyes, his hands from rubbing his eyes. But he's going without the eye patch, but he's been squinting his eye, and I think slowly he's starting to open his eye. So it happened 2 days ago. So hopefully he'll recover okay. Did you have any interesting ER visits with your kids or nieces, nephews?
No, they love coming over here because I let them have this one room that they can completely destroy if they want. I mean, I still have all their pictograms on the walls from when they were growing up in there.
Okay.
I won't paint over them.
Right. Yeah, that's fun.
Little pieces of history everywhere. What's going on in their tiny little brains?
It is funny to see them draw. I just recently got one of these easel. It's an easel with a whiteboard on one side and a chalkboard on the other, and a whole bunch of multicolored whiteboard markers. And my son Orion has been drawing some very, very interesting things. Lately, he's been drawing the tornado from Elmo's world. So he just draws it as a big black triangle, a big, like an upside down isosceles triangle with eyes and eyebrows. He loves My Little Pony, so he does lots of My Little Pony drawings. But he's a funny kid. Meanwhile, Mars just scribbles. Orion's got a lot better hand-eye coordination. But Mars he's our scribbler. But it's fun to see him develop. So, any interesting videos you've watched presenting a new facet of the debate?
No, I was on that other channel last night, and I got booted twice.
The 3chan.
Yeah.
Yeah. I don't think I'll be going back there.
Just for well, I was. Oh, it was last night. I was in a unique position of defending you.
Oh, interesting.
Yeah.
Do tell.
Well, they were saying, how you must be a troll, a paid shill, because it seems you can't be rattled. And this guy was going on. I don't know. Their names and their personalities blend to me, so I don't know who they are.
Right.
He goes, oh, I tried I tried all my shit with him. Same shit I used on my teachers. Blah blah blah. I was like, well, dude, he is a teacher. He's heard all this shit before. Right. So your attempt to push his buttons don't work, and suddenly he's a paid shill because you don't know how to push buttons.
Yeah, that sounds like Michael Craig, otherwise known as Hitchhiker. Yeah, and it's like, I kind of thought that I was getting to a place with him where, there's certain people who have to be the asshole first. And I see that with some students. They have to be the asshole because they are trying to see if you can survive them. And if you can survive them, you've just earned a position that now you've demonstrated like your mettle, so to speak. And so I kind of thought that I was getting there with him, that he was 100% asshole all the time. I mean, like, he never greets me without calling me a faggot. And it's just over and over and over again. But I'm thinking, like, I'm actually starting to understand where he's coming from. Blah blah blah. I mean, he seems like a teenager. But then after a while, then he started banning me from the chat room. And then there was this other thing where that person who shall not be named, I was just making comments to the people who were in the Hangout, the people who were speaking in the Hangout. I was just in the chat side of things, but I was just typing things like, "Oh my goodness, they're talking about dark matter." Sigh. So I was just, I guess I was a little too snarky. But meanwhile, Michael Craig gets in. He's like, effing faggot, you just effing faggot. And I just like sigh. And then this woman, she's like, you keep it up, and you're gonna get banned. And so it's like, okay, so here you have somebody who's just cursing me out up and one and down the other, and I'm being snarky in response, and I get banned. So I got banned. So took a couple days off, came back, and then next thing you know, Michael Craig, he's got a wrench. So just for fun, and I'm right in the middle of engaging people in the chat, just engaging. People are talking back and forth, they're asking me questions, or they're they're not necessarily asking me questions, or they're debating with me, going back and forth, right in the middle of several conversations. And Michael Craig puts me in timeout just for fun, and it's like that's not just an asshole, that's a teenage asshole, and so I don't think I need to go back there, because but that's the guy. I mean, I've actually heard where you could listen to the Hangout without necessarily typing in chat, so it's like they could be speaking about you and they don't know that you're actually one of the people listening. And so I heard him say, like, yeah, I tried all this stuff with him, and couldn't rattle him, whatever. I mean, he has rattled me. He has gotten under my skin at least once. But it's like at some point it's just not worth the effort. He's like, the reason why I'm here is to engage people with ideas. I know there's some very honest seekers, some very honest people who are taken in by some of these very, very compelling flat Earth videos. I mean, some of the stuff is really slickly done, and it's like, if you watch these videos, like, you'll be convinced the Earth is flat. So it's like, then I'll come in and I'll try to engage with them in some ideas. So yeah, I'm sorry, Gerald Sam, but yeah, some people, it's just, I don't know. At some point, other people are more worth the effort. Like, I'm not going to spend all my time trying to argue with a 19-year-old.
Exactly. The thing, it's a lot of people, because I used to be heavily involved in the creationist debates here on YouTube, and only for one reason. I don't care. I simply do not care what you believe in the privacy of your own home. But if you want to take it out of the church and into the school system, then you've got a beef with me. So and I never unless they bring it up first. I don't attack anybody's belief. If they attack me, it's like, well, you're an unbeliever, therefore blah blah blah. Well, now we're going to have to talk about your belief, aren't we? I'd rather focus on what science you have on your side, what you can prove, what you have evidence for. And last night I was actually pretty. When I came back the second time, I went under another channel name and I introduced myself as who I am. And I said, listen, there'll be no vitriol. I'll just calmly and coolly. And while I was gone, I heard them saying that I must have a script, that I must be working off a script, or I have several web pages open at all times. No, baby, this is coming off the top of my head. It's only the aerospace industry, satellites and astronomy, and especially our solar system, is just my passive hobby. I'm very interested in it, as is my oldest nephew, so we do it together. I can't get enough of this stuff, and I love it. So even I don't know how many facts I've got in my head, but when I hear somebody spouting bullshit,
right,
to the reception being a clap on the back, yeah, you're right. Any kind of bullshit you just pulled out of your ass a moment ago, going unchallenged, doesn't happen in my world, not on my watch anyway. So then I'll come on, I'll leave my little avatar sitting there stalking them,
right,
and suddenly they try to start making sense, or I never said this, before I even say a word. And then I come on and I challenge them directly on everything they said. Where are the facts? Where are the figures? How do you know this? The usual questions. I don't need extraordinary evidence. I need as much evidence as you can supply for having had breakfast that day.
Right.
That phrase, extraordinary claims require extraordinary evidence. I don't believe that at all. I believe it requires only the most mundane of evidence.
Well, it's the extraordinary claims part.
If you cannot prove that any more than you can prove what you had for breakfast that day. So
yes,
and if you could, guess what? It has jumped to the next level for me. But since you can't, it never does.
Have you ever heard of a YouTuber by the name of Michael Hansen? I think he's Dutch. He's from one of the Scandinavian countries, or maybe it's even, I don't know. I'm just making this up. But he's a astronomy. He's a postgraduate. I think he's working on his PhD, but his topic is gravitational lensing, and he's jumped into the flat Earth debate by making a couple of response videos to some of Brian Mullen's stuff. But in one of Michael Hansen's videos, he was talking about proof, and I have zero training in this, so it's like I'm going to go off the deep end because I don't have any training in rhetoric or philosophy or fallacy or argument. Okay, so I'm just making this stuff up. But he said something very interesting.
I'm not a logician either.
Yeah, I would love to learn more. But he said something very interesting. He said there is no proof. He said there can be no proof, and I thought that was a very bold statement. It's like, what do you mean there could be no proof? And it's like, when you think about it, there could be like some of the most fundamental things, but you couldn't prove it. Like, I was even thinking you could take a guy and you could rocket him, on up to the ISS, and guess what? It wouldn't be proof because, for number one, he's on a motion simulator. Number two, every screen he looks at, every window he looks at is a 4K monitor with like 3D perspective. And all the weightless stuff. Well, that's all done because they're actually on a zero-G airplane. And it's like, so if that guy did not believe that the ISS exists, you could take him on the ISS and he could conceivably still believe it was just smoke and mirrors, that you were just taking him on a ride like Disneyland. And so I thought that was very interesting about proof. It's like there is no proof. And that's something I put in my videos, is at the very end of my videos, when I've just told people how they can measure the speed of the sun across the sky, and here's what it should look like on the flat Earth model, here's what it looks like on the globe Earth model, what's your data show? And then I say, but this isn't proof. Your data simply supports one model over the other. But that's interesting about the extraordinary claims require extraordinary evidence. I think that 9/11 being an inside job, I think that's an extraordinary claim. That you have to have all these people.
Well, then again, all you need is the most mundane evidence for it, of which there's none.
Well, but their mundane evidence is the fact that they've got some firefighter who, before the first tower collapsed, he's yelling at people on the plaza in front of the building. You guys have to clear out of the area. There's still a live bomb in the building. I've never seen this video, but apparently there is a video of a firefighter directing people. So, and it's like, so okay, maybe he's using language that people can understand so that they know to evacuate it immediately without asking a bunch of questions.
Or this situation is still a live bomb. Move away.
Right. So it's like, but that was given as a piece of evidence in support that there was a bomb in the building. And it's like, so finally I had to concede the point, like, okay, this firefighter, I'm not going to question his professionalism or his demeanor, but okay, so let's say he said exactly that. Is there any other evidence that there was a bomb in the building? And then they start going off about the smoke plumes coming out, during the collapse. There was a blast of smoke or fire like 10 stories below where the collapse zone was. Like, this is during the collapse. And it, that make sense to me, and that maybe, fire is traveling down elevator shafts and stuff and then blowing out the sides. I mean, I don't know.
Melting through floors.
But, it clearly, the building hadn't collapsed down to that point, it hadn't, pancaked down to that point yet. And so well, how come that, so that's evidence that floor was taken out with demolitions, So it's there's their evidence, so.
Yeah, that's not evidence. And I still use the word proof and prove because, you know why? It sounds better. Yeah. Prove it. I understand that, in science, there cannot be 100% proof or certainty. It's always subject to change. But some things aren't going to change, and you're still not going to say it's been proven, quote unquote. But I still use the word because, hey, I don't care.
Right. But I would like to learn more about, especially about things like logical fallacies, because
you know what? The fact that there's a term for them doesn't prevent you. The fact that you don't know what the terms are doesn't prevent you from recognizing the fallacy. You say this is wrong. I don't know the name for it, but this is what you did.
Yeah.
Well, if you look up a logician's handbook, you go, oh, that's the fallacy from incredulity.
Right. The thing is, it's nice to have a vocabulary for things. When you can give something a clear name, then it's easier to refer to that thing. So if somebody is using, I'm starting to be more familiar with, say, argument from incredulity. I could then call them on it, and I could say, you are using argument from incredulity, as opposed to using 10 times as many words to describe how he's using argument from incredulity without actually naming. Do you see what I mean? Because argument from incredulity, you can go to a wiki page, you can look it up. It's described. There's lots of examples, and it's nicer to name that. If I'm going to call somebody out on it, I would like to know what the name is. But that's a classic one.
I just pretty much tell them in their own language. Yeah, so you don't fucking believe it. What does that mean?
Yeah. Well, do you feel like you're spinning? Do you feel like you're on a spinning ball? So are you familiar with I'm going to call this the mad helix animation, where it shows the solar system and the sun, and it's this wildly corkscrewing animation. It's a beautiful animation. I mean, the guy who did it was not a flat earther, right? Do you know
showing our motion in the solar system and also incorporating our motion through the galaxy?
Yes. And so basically we're headed north, I think.
Yeah, I think we're going upward on the plane of the ecliptic plane.
Right. So they love to throw that in their little videos about, do you feel like you're moving? I mean, does this make any sense to you? And again, proof or argument from incredulity. So I finally did the math, and I'm just wondering, because you're a kindred spirit. Do you have any ballpark ideas as to how much speeded up or sped up that animation is compared to real life?
Oh my gosh, it must. I mean, you talked about the RPMs of the Earth. You can talk about a complete revolution around the sun, and now we're talking about how fast the spiral arm of the galaxy is moving.
Yeah, well, I don't know about that. I'm just talking about the speed of that animation, which does show orbits around the sun. I don't know anything about the speed, through the galaxy.
I think I saw that video. I haven't looked at it recently, but it crops up the image, or crops up in other videos that I see, and I guess it looks sped up. It should. We're not a pinwheel.
Give a ballpark number as to how.
Goodness, I don't know.
Like how many times faster than reality is that animation? Just off the top of your head.
Oh my! You know what? Ballparking it.
Yes.
From what little I can remember of that video and what I think actuality is, I would say 1,000 times.
Okay, that's a fair estimate. It's 300 million times.
I was gonna go with the B word. I was gonna go with billion. But
300 million. And so what I did is I timed Saturn. I counted Saturn because it's very visual. And so what I did is I paused the animation when Saturn was on the top, and then I had the animation playing at 1/4 speed. And so I just took a note of the time code, and then I pressed play, and then I just counted for 4 revolutions of Saturn. And then I took how many seconds that was, and then did the math with Saturn's orbital period, which is 13 years or something around the sun. Yeah, 300 million times faster. And so do you think that it might be a little bit dishonest for people to trot out that animation when talking about how ridiculous our solar system is? It's like these people,
Saturn traveled at 30 years around. It takes 30 years, Saturn.
30? 30? Okay, I thought it was 13.
Saturn years, 30 Earth years, I believe.
Oh, okay. Now I'm not taking into account. Okay, so you're right. I'm not taking into account like Saturn's like days or anything like that. But yeah. So I did the math, and so it's a beautiful animation, but it's extraordinarily sped up. There's another animation that's a similar one that just it's showing like a month of moon phases, and so they show this Earth, and this Earth is spinning like a top. I mean, it's spin as this moon is like just traveling around the Earth, And so again, I did the math, took the time code, and it went, one complete orbit. I was like, all right, so that's 28 days, and just do the math, and that was, some ridiculous number, that was like in the hundreds of thousands of times faster.
Well, if they didn't show it at that rate, I mean, it would be a pretty picture, but pretty dull to look at after a minute, because it wouldn't be moving.
Somebody did the math with like one of the Himawari 8 imagery, and I think the Himawari takes a picture every 10 minutes.
Every 10 minutes.
And then they figured out, what's the pixel resolution? I think this might have been Coolheart Logic.
11,000 by 11,000.
Okay, it's amazing. But it turns out that they say, oh, if the Earth is spinning, how come you don't see all this motion blur? And it's like the motion blur on one of those images is 1/10 of a pixel. It's like, that's how fast the Earth is spinning. The Earth is spinning so fast that the motion blur in that image is 1/10 of a pixel.
But it's also a geostationary satellite. So
I'm sorry, not the Himawari, but maybe it's the
Discover. That's
the Discover, right. Discover.
I'm just about to incorporate that in my next video, so all my research is coming up.
Yeah, and is that the L2? The L2 Lagrange point?
It's in the L2 point.
Yeah, it's amazing.
One of the Lagrange points.
If you look at Lagrange, I mean, he figured these points out.
Joseph Louis Lagrange predicted them. And
predicted them using mathematics and physics, like before, 50 years, 100 years before the first rocket engine was invented. I mean, that's the thing that flat earthers don't understand is like people actually did real math and science before we went into space. They actually measured stuff. They actually knew things about our world without going into space and taking a picture. They were very knowledgeable people, and there's really lots of stuff you can do with math and physics and geometry without going into space. Oh my goodness!
You try to tell them that, but they can't keep NASA off their lips.
It's a big conspiracy.
It's huge.
I love the story of the, I guess it was introduced to me by Jesse, is it Kowalski? There's some person named, is it Jesse Kozlowski, who's like some female star of one of these MTV reality shows, and I can't keep her name and his name separate. One is Kowalski and one is Kozlowski. But anyway, Jesse the surveyor, the geodetic surveyor, and he introduced this topic that I'd never heard of before, and that was determining whether the Earth was a oblate spheroid or a prolate spheroid. And there was a debate, and the debate got settled. And do you know the year that this got settled via surveying? It was like 1735. 1735. They sent surveying expeditions to South America and to Lapland, which is now, I guess, Finland. And it's like, and they took very, very careful measurements, and they were able to determine whether it was oblate or prolate. Just amazing. But it's all NASA. NASA lies.
Prolate meaning what? Elongated the poles?
Yeah, elongated, more like egg-like.
Like
stretched towards
top to bottom, rather than side to side.
Right.
I was like, prolate. What does that even mean?
Yeah. I had to look it up because I'd heard oblate spheroid, and that's, I guess, oblate spheroid is when two of the three axes are larger than the third axis. Prolate is when one of the axes is larger than the other two. The other term is ellipsoid, and an ellipsoid can have three different axes with three different measurements. So it's I learned all this stuff recently from debating with flat earthers. I didn't know all this stuff before.
Well, I have to get back on my maths because I want to go back to school and study astrophysics. And I can't do that without math now, can I?
No.
So I have to bite the bullet. I mean, I'm pretty good once I get up to algebra, but then beyond that, I start getting shaky, and it's like I don't remember any of this stuff.
How far did you go with your, or like what did you study? When you were in school?
I studied literature.
Okay.
I mean, I had the basic requirements in high school and college.
Right.
But I pretty much got past basic physics. But it's and I remember at that crossroads of my life, going, okay, what am I going to study?
Right.
And I made my decision. I said, you know what, I could learn all about. I was very interested in physics and maths at the time. I said I can learn all that on my own, but I never did. I mean, and I know that I can now, but I'd rather have a tutor or take some remedial classes just to bring me up to speed. I could take some non-credit courses to drag me up there. And then there's Khan Academy online.
Yeah, I was just posting that in the chat room.
Oh, yeah.
Have you seriously poked around in Khan Academy, because it's really nicely organized now?
Oh yeah, I think I got started, but then I kind of just drifted off, and I want to take it up again. I still have an account there.
Okay,
but I wanted more of like a tutorship.
Okay. The thing is, tutoring is expensive. Mm-hmm. So what I recommend to folks.
I got the money.
I'm sorry.
It's okay, baby. I got the money.
Yeah, because I mean, I work as a tutor in nights and weekends during the school year. And I'm not, I'm actually inexpensive as tutors go. But it is expensive. But I tell people, learn as much as you can through, say, Khan Academy. And one of the nice things about Khan Academy is it's videos plus practice experiences, and they've really done a nice job with that. You can't have considered to have practiced something, like really practiced it, until you get, say, like 5 problems right in a row. And they really do a nice job with, like, not just random number generators, but they really give a nice variety to the problem. And then it will, if you click on, I think it's something called mastery challenges or something, where it will keep revisiting the stuff that you've already learned. It keeps cycling back through, and it keeps giving you more and more questions, sampling from stuff that you've already practiced.
Right, I noticed that about them. But what I wanted to get more hands-on, so I went to Amazon and ordered high school textbooks.
Okay.
Algebra 1, Algebra 2, Calc.
Right.
I pretty much got the full line from Prentice Hall.
Okay.
So, but they are more like, I think they really need a teacher's guidance, because a lot of it, they're not really very explanatory. They're just these are the problems, and if I had the thing is that I had a lot of questions when I was going through them, and there was nobody to ask.
Okay.
So,
well, you can ask me anytime. I'm happy to help.
Thanks. I may take you up on that.
Yeah.
I don't care what you charge. Trust me. The university I'm going to be attending is going to cost a lot more.
I'm happy. I'm always happy to help. Because it's like, the thing is, I'm a teacher, but I'm a teacher at heart. Like, my goal is for people to learn something that they didn't know before. Whereas other people on the Flat Earth Debate, they're like, oh, well, you're a teacher. That means you're a part of the indoctrination process. And it's like, I am the last person that you would want to put in charge of any indoctrination program. I mean, people don't realize how iconoclastic and how non-conformist I am.
You were in the Hangout once, and I was just in the chat, and somebody said in the chat, he said, "Damn, being a professional teacher, you'd think he'd like to, take a break once in a while." And I wrote back, it's like, well, true teachers can never stop.
Right. Because it's part of my being, like some people. I'm sorry, I'm writing something in the chat. I'm sorry. Some people get their self-esteem from planting a garden and seeing it grow. Some people get their self-esteem from, building a special effects sequence for a movie, and then it comes off looking really cool, and they're like, job well done. And it's like, I get my self-esteem from imparting knowledge and skills, helping people grow, helping people learn. So we got this guy, Scotty Storm, in the chat. Scotty, if you have any questions, so like, for example, NASA legit, whatever. I believe that NASA has never lied to me. That's really one of the key things about NASA lies. I don't have a single example of NASA lying to me. Scotty Storm, I was just Atheist. I was just on it was a video taking a look at 2 pairs of images, one from Apollo, I think one was Apollo 12 and the other was Apollo Was there an Apollo 17? Was that the last one? Nope, not once.
Apollo 17 was the last.
Yeah. And so these two pictures were taken of, it was very interesting. There was a very distinctive, like a pass, like a mountain pass. So you see the lunar lander, you see an astronaut, and then you see this, it looks kind of like a saddle. There's a hill, and there's a low spot between the two hills, and very, very distinctive. And then there is another photo, and no lunar lander. The ground is different, and the mountain pass is exactly the same way. And so, clearly that was a painted backdrop on the set, and they moved the lunar lander, and they moved the dirt around, taking a couple different pictures. And I was like, okay, so it's a background, it's a painted background, and it's a movie set. And so it's like, so I start looking into this, and I start really, he even went so far, or it was she, as to superimpose the image, and you could see the differences. It's like, belief is so strong.
Here's one thing they don't take into account. There's no atmosphere there. There's no appreciable atmosphere by any stretch of the imagination. And those mountains with the saddle, the gap that you're looking at, are far away.
Yeah.
And it's like if you move 10 feet to your right, Mount Fujiyama is not going to change perspective. So
yeah, it's right. So I jumped into the rabbit hole, and I started doing my homework, and I learned a whole lot. I learned so much about the geology of the moon, how they selected the landing sites because of certain geologic formations, that they would get the most interesting soil samples. These guys really knew what they were doing.
They found Genesis rock. Early solar system.
It's amazing what they found. But so I found what that mountain was, and it turns out it's 10 kilometers away. 10 kilometers away.
Exactly. And the part about no atmosphere, it looks crystal clear with deep focus, because there's just nothing to make it look hazy, and that's what they're expecting to see. It's not analogous to Earth by any means in that respect.
So Atheist, we've got this guy Scotty Storm, and I don't want to just type responses. So do you mind if I'm just gonna start talking to him? So Scotty, you raised some very good points, and I'm a huge fan of Occam's razor. So I guess you just joined fairly recently. My senses tell me that we live on a flat, stationary plane. Okay, so when I go to the beach, I see a flat horizon. It looks razor sharp. With a ruler, hold a ruler up. If you go into a plane, the horizon still looks flat. If you consider how fast we're spinning on our axis, I'm supposed to be traveling 800 miles an hour on the axis because I'm outside Philadelphia, and I don't feel motion. I don't see a curved horizon. So Scotty, you're exactly right. Your senses tell you. My senses tell me that I live in a flat stationary plane. So by making very careful observations, and I say looking up in the sky, but you can also look at the horizon. You can measure the curvature. So Scotty, it says no experiment has ever found a curve. That is absolutely mistaken. The thing about the experiments that some flat earthers do is their experiments are always dependent on very, very low observation. And these people are very earnest. They're trying to see curvature, but they put their camera down right next to the water, and at that level, just refraction alone is going to cause the light rays to match the curve of the Earth. So you could be 10 miles away, and you could see somebody on the beach, and you're not supposed to be able to see somebody on the beach 10 miles away, according to the globe Earth geometry. So Scotty, you have a very good question. What I would say is, if you go higher in elevation and you perform experiments or observations at longer distances, then you will start noticing the curvature by what is missing. And the classic example is the observations of Chicago across Lake Michigan. Now I'm going to post a link. I've got very bad bandwidth, so I don't want to do screen sharing, but I am going to post this into chat. Copy link. All right. So these are images showing curvature. Now the thing, Scotty, is that you're not going to see curvature, meaning you're not going to see a curve. So if you're making observations on the Earth, you're not going to see the the curve of the Earth. You're not going to start seeing curve until you get 70, 80,000 feet in elevation, like from some high altitude balloons. But most of those use GoPro lenses, so it's hard to detect the curvature because of all the distortion. So Scotty, you have to understand, if you are making an observation. So for example, if you go into that folder, there's a couple images. One of those examples is of observing an island from 130 miles away. Now, how can you observe an island 130 miles away? Well, it's going to be part of the mountain is going to be missing because it's going to be behind the curve of the Earth. Now, you aren't going to see the curve. You're going to see a flat horizon because you're looking, your angle of view is not thousands of miles wide. Your angle of view is a lot more narrow because you're looking at this mountain, or this island. It's called the Island of Reunion, and you're standing on Mauritius or Mauritius. I don't know how to pronounce that. And so you can see that the island, and if you take a look at the topography of the island, that has a certain mountain. The mountain is supposed to be a certain height, and all you could see is that mountain cut off. You don't see the whole mountain. I think what is it, like 2/3 of the mountain it's close to 2/3. It's about half the mountain. The mountain is named Gross Morn, and about half of it is obstructed. And so how come half it's obstructed? Well, it's obstructed by the curvature of the Earth, but you're not actually looking at something that is curved. I don't know if that made any sense. It looks like you're engaging Gerald Sam.
Yeah, the part we keep leaving out is that the curve goes away from you.
Right.
And a simple ship sailing over the horizon proves it every day to everybody who ever sees it.
It's really, really tough to see something that is curved on the Earth. I mean, the Earth is just so freaking huge. And this is actually one of my side projects. It's a side math project, and I haven't finished it. I've just got a bunch of notes, bunch of scribbles. And I was trying to come up with a mathematical formula for the visible curvature. In other words, if you have an observer and you elevate the observer and he's looking at the horizon, at what point will the observer notice a curved horizon? Because you could look at the endpoints. You're standing on the beach and you're looking at the horizon. The horizon looks as straight as a ruler. Now you are on your way to the moon. You're 100,000 miles away from the Earth, and you're looking back and you see the entire circle that is the Earth. In other words, the horizon, which is the tangent to the sphere, is now a perfect circle. So how do you get from a ruler to a perfect circle? At some point, that ruler had to start to bend. And so my question is, at what point does that ruler start to bend? And you run into problems of human perception, and you've got peripheral vision, and it's a big mess. And the math gets really, really crazy, especially if you just want one input, and that is the observer's height above the Earth. If that's your one input, the math gets really monstrously complicated just to try to figure out how much curvature you can see, how much curved horizon you can see. But it's a problem. It's a puzzle. Yeah, Scotty Storm. That thing about the boats. If you zoom in, you could see more boats. That is such a. It's just been repeated over and over again. I'm going to attempt screen sharing. Please let me know if I start breaking up horribly, and I'll drop out. Yeah, Scotty Storm. People say that about math. Math cannot be used to show whatever you want. Math does have restrictions. Let me see if I could. Okay, so Scotty Storm. I hope you can see these images of these were taken. These are screen captures from Rob Skiba's boat ride, and you raised an interesting point, which is that people say if you zoom in on the boats, with a stronger lens, stronger telescope, that the whole boat comes back into focus. And what they mean is that if you have a little guy, a small boat, and that boat is like 3 miles away, and you're looking at it with your eyes, you could probably say that boat disappeared, right? But literally, the boat did not disappear. The boat got too small for you to see. So if that boat is only 3 miles away and you're standing on the beach, the boat disappeared because it got really small. A boat at 3 miles away, a small boat at 3 miles away, is going to be very, very small. so it may disappear from your vision. But then you lift up a binoculars or you take a zoom camera and you zoom in, and all of a sudden there's the boat. Now, the boat didn't disappear because it went over the horizon. It disappeared because it got so small. So here's a question for you, Scotty. We could talk about Airy's failure in a little bit, but if you could see the images of Chicago, the very last image was exactly the first image. He was starting on his boat journey, 42.6 miles away, and you could see the Willis Tower, or otherwise formerly known as the Sears Tower. And the thing is, that could be, you could call that the mast of a tall ship, a ship that's, I don't know, 1,500 feet tall. And so this was taken with a zoom lens. This was taken, maxed out on his P900 camera, which has got, one of the best optical zooms of any camera. And so no amount of zoom is going to cause the bottom of that building to come back into view. No amount of zoom is going to cause the entire city of Chicago to come into view. And all you could see is the top of that building and the top of two other buildings. And then we've got the other three images where he's getting closer and closer. And, it's very interesting. For some reason, the Willis Tower appears to be growing taller. So either the Willis Tower grows taller, or you're going over the curvature. You're going closer to the building. So it is coming, sort of rounding over the curvature towards you. So it becomes taller. It's not actually taller. It just looks like it's getting taller. Now, this photograph is taken of the island of Reunion, and this is clearly with a zoom, a very, very fine telephoto zoom lens. The island of Reunion is not a huge island, and it does have a couple mountains on it, 10,000 feet, so almost 2 miles tall. But you can do the math, and you could figure out exactly how tall, for example, the Piton de Niegas, I don't know how to say that, but that mountain is supposed to be 10,069 feet tall, and it is only so many feet from Gros Morne, which is a very similar height, a little bit less than 10,000 tall. Well, you could do the math, and you could figure out, okay, so if it's that tall and it's so many feet next to this other mountain, then, well, here's where the shoreline needs to be. And so the actual shoreline is concealing, or the curvature of the Earth is actually concealing 60% of the mountain. And then so you go from where the picture was taken, which is the island of Mauritius, and then I looked up an elevation map, and anywhere that's red, orange, yellow, and green is all of the appropriate elevation to result in this photograph. In fact, just the red areas, just looking at the red areas, you could have taken that photograph with no refraction. And so that's a wonderful example of a measurable observation, measurable, with actual data, actual measurements on it, showing the curvature of the Earth. But you look at the horizon, and the horizon's not curved. That's because we're looking at only a couple miles of horizon. But this island is 140 miles away, so we're obviously zoomed in with a very strong telephoto lens. So Airy's failure. I'm going to stop sharing if I can. I'm going to close this window. Okay, so hopefully I am not sharing anymore. I'm going to turn down my bandwidth. Okay. So Airy's failure was the failure to detect the Earth's motion through ether. I'm going to say that again. Airy's failure was the failure to detect Earth's motion through ether. And so there's two ways of looking at that. One is that the Earth is stationary in the mass of ether that is propagating light, because they thought that light had to have a medium of propagation, so they thought this medium of propagation was ether, just like air propagates sound. So one possibility when Airy had his failure is that the Earth is stationary in a sea of ether. The other explanation is that the Earth is moving and there is no ether. So that's one way of looking at the failure, is he failed to find motion through ether. And you could spin it either way. I mean, you could say, yeah, it proves that you're a flat, motionless Earth surrounded by a sea of ether. So you could spin it that way. But there are other experiments that determined that there was no ether. So it's kind of silly. But all the observations that you can make, and this is one of the reasons why I tell people to look up. You're not going to find the motion of the Earth by looking at Chicago across Lake Michigan. You're going to find curvature. You can measure curvature looking across the lake. So that tells us we live on a globe. But you're not going to sense the motion of the Earth, the spinning of the Earth on its axis. That you got to do by looking up, and by taking very, very careful measurements. When you look up, you can literally determine. And I just learned this fairly recently. I kind of stumbled on it by accident. you can actually experimentally figure out 23.5 degrees. You can experimentally figure out that our year is 365.25 days long. That's not just an estimate. That's a fairly, well, it's close to an exact number. There's decimal points after that. And you can actually do this by making careful observations of your sky. There was I was looking up some of the old astronomers, and there was I guess he was an Arab, or he was an Arab astronomer, I think. But anyway, when he was 19 years old, he measured the tilt of the Earth's axis as 23.5 degrees. And it's like, well, how could a 19-year-old do that? Well, what he did is he carefully measured the sun, and he carefully measured the sun at zenith on the winter solstice, and the measurement of the sun at zenith on the summer solstice, and also at equinox. And if you take those three measurements, both solstices and both equinoxes, you will find that at equinox, the elevation of the sun is 90 minus your latitude. At summer solstice, it is that angle plus 23.5. At the winter solstice, it's that angle minus 23.5. So anybody literally using observations in their own backyard, of course, you need a bunch of months on the calendar, you could literally measure the tilt of the Earth's axis. And the interesting thing about 23.5 is it never shows up in the flat Earth model. The number 23.5 never, ever shows up. And it's because their model is an approximation of what you could see if the Earth were flat, but they have to fake a whole lot. Are you still there, Scotty Storm? Is anybody still there in the chat room? I do have to go because I have church in the morning. My dear wife and children. I was just talking at the mic. Sorry, I scared off Atheist Rex, so I was monopolizing the microphone. I don't even know how many people are. Hello, Gerald Sam. You got anything to talk about? I see you. You were doing yeoman's work talking with Scotty Storm. I don't know if he left, but what's your avatar, Gerald? It looks like I'm not sure. Oh, 6 people watching. Because I've closed that YouTube screen because of my bandwidth issues. So, but anyway, I'm really discovering a whole lot of things that you can figure out just from your own backyard. No, not a problem, Andrea. I happy to be of service, but I do have to go soon. I was supposed to be here for a half an hour, and it's been like, I don't know, 2 hours. But yeah, so I think I'm kind of running out of ideas and things I can talk about. Oh, Saturn's hexagon. I should have recognized that. Yep. Now, you know what Saturn's hexagon proves, Mr. Gerald Sam? It is just yet another proof that the Earth is flat. Because if the Earth were a globe, there's no way they could be a hexagon on Saturn's North Pole. You understand that? That's the logic of it. Because reasons, as Red's rhetoric likes to say. So they're going to have a really interesting launch of the Falcon 9. I don't know when the launch is. I think it's coming up, if not tomorrow, in the next day or so. And it's going to be a groundbreaking one for SpaceX in that they've been fairly successful, not 100%, but they've been fairly successful boosting the upper stage into space, into orbit, and then the booster, first stage booster, comes back down, lands on a barge. What they're going to try with their next launch is they call it a boost back, and so and I don't know how they're going to do this because when the first stage booster is delivering the second stage, with its single engine, it's going like 10,000 miles an hour, and it's going 10,000 miles an hour and a bunch of miles downrange. But what they're going to try to do is they're going to do a boost back, which means they're going to turn the rocket around. They're going to hit that engine again so that it is flying back towards Cape Canaveral, and they're going to attempt to land on a concrete pad at Cape Canaveral. And I just think the engineering behind that is just mind-blowing. Mind-blowing. I can totally understand how you can land on a barge because you just park the barge, near where you do main engine cutoff, or downrange. And I really don't know how they're how the engineering behind it. I mean, obviously I'm not a rocket engineer, but this is going to be a really groundbreaking moment. If the thing is, if it's a horrible failure, they're going to collect a ton of data. But yeah, definitely hope they succeed. But it's like what a lot of people don't understand about engineers. Engineers collect data, like succeed or fail. Engineers collect data. They love data. I was looking at some really phenomenal footage taken from the space shuttle launches, and these were filmed with something like 40 cameras, with like super high speed, like 240 frames a second film cameras in these very special housings with like quartz lenses that protect them against the blasts and heat and fire. And there's this really, really nice series of YouTube videos dedicated to the space shuttle, and more specifically it's dedicated to the men and women who made the imagery. The launching camera equipment is just amazingly complicated. Like, if you're shooting 240 frames a second and it has to be in a remote housing, and you just need to capture the 10 seconds of the shuttle clearing the tower, or less than that, like, how do you remotely trigger something like that? Because you want the camera to spin up, you want the camera to record all the interesting data before liftoff. So anyway, and it's a nice thing about today is, like, with GoPro and stuff, is that they put GoPros all over these SpaceX boosters, and they get some pretty amazing footage there. But yeah, I definitely hope they'd succeed. But like when they were trying their barge landings, they had a whole lot of failures, very explosive failures. It's like they get better. They get a little bit better each time. They learn something new. They experience a failure, and they're like, okay, let's tweak the design. But yeah, it's pretty amazing. Tesla's auto drive. Yeah. It's a shame that there has to be, like, for example, fatalities with Tesla. And I'm sure they've got a lot of data from that. I don't know if it was the car. I don't know anything about it. But the thing is, if you're driving a Tesla and the Tesla is, it couldn't be a self-guided car, and somebody jumps over the median line and hits you head on, like, your Tesla could be the most amazing piece of equipment, but I can't imagine that it will protect you from other driver error. So I really don't know what happened, but I can only imagine that it was not like computer error, but it could be. Sometimes people like to blow things out of proportion. Sometimes the media, if it bleeds, it leads. And so I remember years and years ago when there was, like industrial robots, outside fault. Okay. Thanks, Gerald. I didn't know any of the details, but this was way back in the 1980s when, industrial robots were starting to really, hit assembly lines big. And there was, it made news, was like the world's first death by robot. And, science fiction has had robots in it for years and years and years. And so, like, the picture that the headline paints is like some humanoid robot that, gets angry at its master and, kills its master. And, obviously the actual truth of the matter was you have a robot with large heavy moving part. And if you take a human operator and you have him stand where these large heavy moving parts are, you're going to get killed by that robot. The robot's not going to have compassion on you standing within its radius of motion. So that's really what happened there is it was really a human error. The robot was just doing what the robot does, swing, stamp. And a human got too close. But it made headlines, world's first death by robot. So this Tesla fatality, I'm sure some people are all sexing that up about the, first fatality for a, computer guided car or whatever. And it's a shame because I'm sure the people of Tesla work very hard, to have as good a product as they can. So, yep. Human error. Oh, okay. Thought it was just a banner. I get you. Yeah. Okay. So it's probably a decapitation injury or at least a severe head trauma. Yeah. That's a shame. Yeah, there was a while that, trucks now, if you look at trucks, they have red and white reflective decals along their length, and they didn't used to. When I can remember when I was, I don't know, a teenager or whatever, I remember reading about this campaign to get trucks to have decals along their length because there were many cases of and it wasn't necessarily that the truck was breaking a law, but there were many cases of people getting decapitated by a tractor trailer because the tractor trailer was backing into a driveway, and so the trailer was spanning the road and the tractor was sort of at right angles. So maybe you saw the headlights of the tractor towards you, and the headlights of the tractor might have been on the other side of the road, like on the other side of the yellow line, but the tractor in fact was backing up. But since there were no lights in the middle of the truck and there were no reflectors in the middle of the truck, if it's at night, you're going to just keep driving, and then too late, all of a sudden you see that you're going to hit this truck. And a lot of people were killed. And so there was this campaign to get trucks to apply decals to the length of the truck, so that if that happened again, it was at night, and somebody's backing up into a driveway, you see this line of reflectors across your path, and you'd slow down. And eventually, I guess, I don't know if they changed the regs or something, but I know the trucking industry, and I was reading some article where it was, the reporter was talking to some, victims of this poor thing, like somebody's loved one had been killed in this type of accident. And then there was somebody who was collecting data on those types of accidents. And then they were interviewing the trucking association, and the trucking association spokesperson was like, oh, this is ridiculous because, it's going to be $1,000 per truck, blah, blah, blah. And I remember at the time remarking to my father that was so ridiculous that, like, why would the trucking association say $1,000? Because we're talking about a string of decals that you could buy at the auto parts store for $5. And then my dad made an interesting point. He says, well, it would be an unfunded mandate. So because people were pushing for the law to change. And if the law did change, then it would be the government ordering truckers to spend money out of their own pocket. So that would be what's called an unfunded mandate. But I thought the thing that really struck me was that the trucking association guy was like, oh, $1,500 per truck, when, you could hire a high school kid and buy a roll of this reflective tape for $5, pay a high school kid $10, and you do it to the whole truck. But that was kind of silly. But that's a shame about the Tesla driver. So I need to get back to bed. My wife is wondering where I am. We got church in the morning. So I am going to sign off here. I am going to take the Flat Earth moderator off of mute if I can. I put you on mute. Now I'm trying to take you off mute. So if there's a Flat Earth moderator in the house, I am trying to take you off of mute and I can't do it. So I'm trying to unmute the moderator, Flat Earth Debates, and it is not working. It's disabled. Control room. Click on it again. I am not able to unmute Flat Earth Debates. I muted Flat Earth Debates. All right. So this is Charles Breeling, otherwise known as Flat Earth Math, and I am signing off. Good night.